At time t equals 0, a small block is released on the track shown with an initial rightward velocity. Assume the block always experiences no friction and right is the positive direction. The block starts at point A, turns around at point B, and returns to point A. And we are supposed to draw the diagram for the speed of the block as a function of time, and the diagram of the horizontal velocity of the block as a function of time. So let's start with the speed of a block. So let's draw a diagram here. This is going to be the speed axis, and this is going to be the time axis. So I'm going to try to draw some straight lines, kind of. So here's the time axis, and this is the speed axis. So I'll just call it V for now. So the first one is asking for speed, and speed is simply the magnitude of the velocity. Like the speed does not, you can't have a negative speed. Speed is just the magnitude. So it doesn't matter if you're moving left or right, the speed is always going to be, the speed is always going to be positive. So I'm not going to draw the negative part of this diagram. So it starts pretty quickly. So initially the speed is high. And then as it starts going up the ramp, it starts losing its speed until it reaches 0. And then it turns around at the turning point B and comes back while its speed starts to increase again. And then it levels off at the original speed that it had at point A. So this is how the diagram for the speed might look like as a function of time. So now let's draw the diagram for the horizontal velocity as a function of time. So the velocity is going to be a little bit harder because you're going to have it go both positive and negative. Velocity can be negative since it's a vector and depends on the direction you're moving. So this is the time axis, and this is the velocity axis. And note that this is asking for the horizontal velocity, so that is a key part of the problem. So again, we're going to start off with quite the high velocity, and then it hits the ramp. And what it's going to do is the velocity is actually going to drop down really quickly for a while because it's asking for the horizontal velocity. And then it's going to keep decreasing. Hold on, sorry. Line might be a little too long if I draw like that. So it's going to suddenly dip down, and then it's going to keep decreasing, and it reaches 0 at the turning point B. And then it's going to continue on, and then it's going to start increasing and suddenly increase as it reaches the bottom of the ramp. So it might look something like this. So again, I'm going to label the points. So this is going to be at like point A, going to point B, and then going back to point A. That's its speed. Now let's talk about the velocity. So it starts at point A, and here you actually have a kind of a sudden drop in velocity because it's asking for the horizontal velocity. It's asking for the horizontal velocity. So as it hits the ramp, some of that velocity is going to change into the vertical component of the total velocity. So the horizontal component of the velocity is actually going to decrease, and it's going to be a factor of the cosine of the angle theta, where the angle theta is the angle of the ramp. So that's going to really suddenly decrease. Now, if we were asking for the whole velocity and not just the horizontal component, we're going to have like a gradual line down like you expect. But since it's just the horizontal velocity, it's suddenly going to decrease. And then the horizontal component also starts decreasing until it reaches 0. And this is at point B. And then it's going to turn around, and since velocity is a vector, it can be negative. So we can have a negative velocity if it's going towards the left. And it's going to keep increasing until it reaches the bottom of the ramp, where all the vertical velocity merges back with the horizontal velocity. And you get this sudden steep increase in velocity. And then at the end here, this is where it returns to point A, and it levels off, where it has the same magnitude as the original velocity, but in the opposite direction. And so these are how the two diagrams might look like, and this is how you would solve this problem here.